Hey everybody, this is Larry, just making my cute vui jump game 9? Wow. Hit the like button and subscribe button, join me on Discord, let me know what you think about this one. So this one I thought, for me, honestly, the most interesting problem of the problem set. I thought I had a good idea, but I keep on confusing myself, and also even after I had the good idea, I got four wrong. Is it four wrong? I got three wrong answers on this one. Um, and yeah, the implementation was tricky in a interesting way. Maybe I don't know if it's that interesting, but for me, pretty okay. So the idea here is that the rules, and let me bring up my drawing board real quick. The idea of the rules with this one is that, well, first, try to understand what they're asking. Is that for every index, right? In every index, you can jump to the right if the number is smaller, or jump to the left if that number is bigger, right? And of course, the tricky part is that you can go every which way, right? So like you have this number that goes to a really small number that goes back to a big number. There are a lot of intricacies here. I think the first observation that I made, which was kind of nice, is that, just kind of play around some scenarios, is just that take the biggest number, right? Well, you're the biggest number, everything to the right of it, okay. Stepping back a second is that I step back a second. Is that the first thing that I thought was that, okay, they're trying to tell you, okay, for every index, try to go to the biggest number. So I was trying to, what do the kids call it these days? Uno reverso. I was trying to reverse that process a little bit of, okay, what if we start at every big number and see if we could work our way backwards? That's the first idea. So then I go, okay, well, in that case, then let's start with the biggest number. What would that look like? What would it look like to go backwards? Turns out for this problem, there is this like symmetry about going left and right, Because you only go right if it's smaller, and if you only go left if it's bigger, right? So it's kind of interesting in that sense, in that if you are at the biggest number, let's say this is max, then it has the same rule, which is that going backwards, it means that everything to the right jumps to max, right? Pretty easy thing to kind of reason out, I think, right? Because if this is max, then one is that if you can jump to it, you want to jump to it because it is max. By definition, you cannot do any better, right? So then my idea is that, okay, you process max and then all the numbers to the right. And then what happens after that? Well, what happens after that is that, let's say you have a second max. By definition, okay, maybe not definition actually. Maybe I'm wrong. Maybe not the second max, because second max can be here and then it just goes to max and you're good, right? But maybe what I meant is that a second max that is outside of the quote unquote the red areas. So this is the second max, right? Bad handwriting. And here you can see that everything to the right of this will jump to the second max, right? Also for the same reason. But there's a caveat, which is that if the second max can go to a smaller number here, then you go back to here. So that's kind of the idea. I actually made a few more observations that were incorrect during the contest, and the reason is just because of tie breaking. And I think I over optimized it a little bit on that. And what I mean by that is, for example, if the and okay, let me step back for a second again, which is that second max, if it can go to any number in here, then it can go to here, right? Well, one thing I left out is that, and this is a critical part, which is that if you could go to any number, then, well, any number would be the smallest number, right? Because if you could go to the smallest number, then you go to any other number. Well, maybe not. But if you go to the smallest number, that's all you need to go to the max, right? All you need is one number, and if you keep track of the smallest, that's good enough. So you have the smallest, right? Okay. Yeah. So that's basically the idea, right? And then, of course, you can kind of what I was saying is that I made an observation, a couple of observations that were incorrect, and so honestly, it's just that if the max here is say 11, right, and then the min here is 11, I collapse them in a way such that the TLDR is that I jump from 11 to 11, which for this problem is actually you cannot. It has to be strictly smaller. So I made a mistake there. I'm not going to go over that. I mean, you can watch the live portion. I actually spent quite a time trying to figure this out, how to resolve it. But yeah. Well, then now, I actually earlier on in the live contest solve part, I had this idea of like union find in a way. I was like, okay, maybe I could just like collapse all of these in a way. And honestly, maybe I still could have, but I kind of dropped that idea early on. But I did implement my kind of merge function, as I would like to call it, though I didn't implement it well because I got a wrong answer direct as a result of updating the wrong thing. So maybe I should have done it with union find actually, now that I kind of think about it that way. But the idea here is that is what we said, which is that, okay, now I'm thinking about it in terms of regions, right? Well, we have this region and this region. Can we merge them together, right? And we can merge them together if the biggest number in this region is bigger than the smallest number in this region. And by definition, of course, the biggest number is going to be this second max. So if the second max is bigger than the smallest number, then you can merge because of what we just did. You can go from any other place, really. I mean, you can go for any number here. You can jump to here and then to here to go to the max, right? So kind of like a working backwards thing, and then you can merge. If you cannot merge, then, well, it's just a sad day, right? It is what it is. But keeping in mind then, that means that, yeah, like every number in between here is also smaller, right? So that means that, yeah, when we have a third max here, by definition, if you cannot merge to here, where yeah, if you cannot merge these two, then you cannot merge these two. I think that's what I was trying to say. And the reason is just some sort of pigeonhole, right? Because you know that, I mean, it's not pigeonhole, but I think it's but the idea is because if there's a number that's small enough here, right, then this number would be small enough to go to or big enough to go to there, right? But that means that if there's a small number, like there does not exist a number that is bigger than this. Let me draw it. If during this section there cannot be a number that is both bigger than this number, but also yeah, cannot be bigger than that number, in which well, I guess that doesn't even matter. It means that this number cannot be bigger than this number if this number, by definition second max, is smaller than this number, right? So that's kind of the idea. Hopefully that maybe I said it a little bit better that way, right? Like and I'll say it one more time, which is that, okay, the reason why you cannot go past all the way, so you don't have to do a loop, is because, and this is kind of like a monostack, though maybe, and now that I think about it this way, I should have implemented it as a monostack, but I did this mergey thing, which is why I got a wrong answer, but it's fine, it still works, right? It's not strictly a monostack per se anyway. It's almost like a in any case, yeah, what I'm saying is that if this number cannot be bigger than this number, because if it is, then it means that this number is bigger than this number, and as a result, yeah, yeah. So if this number is smaller than this number, so they don't merge, then this number has to be smaller than this number. That's basically it. And yeah, and once you merge, the merge step is also pretty straightforward, because now you merge them together. Well, what's the max? Well, the max is that, the max here, and then you also update the smallest, because then now it means that let's say the new smallest number is here, then any future things from the left can go to here, which can go to here, which can go to maybe here, and then here, right? So all that is basically what I want to say. And that's it. I know that I think the idea I got pretty okay, except for the unnecessary optimizations, which led me to took another 20 minutes out of me. But implementation was kind of tricky, so we'll go over it a little bit quickly. Honestly, though, I would also say my implementation is not great. Like I said, I'm giving you this code because this is what I did during the contest, and you can feel free to optimize it and play around with it. If I do it again, I would probably do it maybe not necessarily union find, but maybe more of a straightforward array, or maybe using a stack or something, so it'll be a little bit clearer with the merging, because you only merge with one previous step anyway, right? Kind of. So yeah, in any case, yeah, we set up the answer. This is the prefix, kind of like the prefix sum, but not. But the idea here is that so we went from the max to the second max to the third max to the fourth max, and you kind of see that it is a monotonically decreasing thing as you go from right to left. So I just kind of, but also you kind of, actually let me bring up the drawing real quick. I guess in implementation I kind of skipped this a little bit, but another way that you kind of look at all this, and we'll draw it with height now, right, is that okay, let's say this is the max, right, and this is the second max, this is the third max, right, and this is the fourth max. I mean, they don't have to be exactly the third max, because you can say that there's a max here that's bigger than here, but we already talked about it, so I don't want to go over that much. But you could say that everything now to the right, we can just sweep it like this, right? But as a result, then now you can see that this is monotonically increasing, right? If we just keep track of the quote-unquote the important indexes. Yeah, and that's basically how I structure this one, is that I just run a running max, keep track of max. Whenever max changes, we set the index as current, and then we append it to a new thing. We also update the minimum element within that region, kind of what we talked about. So we have a region, we have the max element, which is the first element, and then the min element, which is inside to the next max element. That's how I keep track for now. And then I just do the merging step, which actually, look at the code, is pretty short, right? I had some debugging because I have some issues, but basically, yeah, I just go from now right to left, and we go, well, do we merge the right chunk and the left chunk to that right chunk, and in the way that we just talked about, right? We look at one element, look at the previous element. If the biggest number from the previous index is bigger than the smallest element, and that's what I have R for. R is a very confusing thing. I wrote R as in like regions, but maybe that could have been a little bit better named. And then I merge, right? And merge, I actually thought about figuring different ways of merging, but first I just kind of update each answer, right? And yeah, the reason why you can do it this way with a for loop is because each element is only going to get merged once, right? So if you have a chunk, everything inside, actually let me bring back the drawing real quick for the merging, right? So if you consider, say, like this one and this one, right, everything inside is already updated, right? So when we're merging, all we're doing is updating this part. So yeah, but keeping in mind that when we update, then now these are merged into one component. So every index can only be merged from the right ones, because if it doesn't merge, then we just keep going, and then maybe this merged to here, for and these elements gets merged, but we don't look at those elements. So as a result, I just thought, I can just do a for loop, amortization, each element gets updated once, and that'll be fast enough. You can also, do it in a past later or something like that if you are unsure. But yeah, and then now for the merge, I just update the things. So I don't actually do a real merge. Maybe I should have. It would have been less confusing. But what I mean by fake merge is that I just, because the way that we write it, we always check the current index with the previous index, so then we just update the next index that we were going to update or whatever. So that's basically what I did here. Though, as I said, I did have a couple of typos and sloppy mistakes here. So doing it this way, trust me, not smart. I don't know, like, yeah. So don't think it is some clever thing I'm trying to do. I mean, maybe I thought it was in the time, but that's why people don't do it. Anyway, yeah. What's the complexity here, right? This is all linear, right? Like in combination. Yeah, this is a linear way. We just kind of do a loop, right? Element one by one. Merge is also of one each, so this is O of n. So everything is just going to be linear time, linear space. And that's it. That's all I have for this one. Let me know what you think. Thanks for watching. And you can watch me celebrate live in the contest next. I have to come back. Maybe I have fresh pairs of eyes. Okay. How long did I take there? That took 10 minutes. I don't get that problem. I don't know. Alright. Nums. I jump to another index j. Okay. Jump to j if j is... I don't know why they will I is less than j, but okay. If... Okay, so... I don't... This is so confusing. Okay. So... I goes to j if num sub j is smaller. Okay. Or goes to the right maybe. Right. Okay, so that's for me just easier visualizing. Goes to the left if num sub j is bigger, is it? Yeah, right. Okay, so you can jump. Okay, fine. For each index I, find the maximum value nums that can be reached following any sequence of jumps starting at I. Okay. Okay, so you have big numbers. You want to be able to jump from everywhere. This is what you might call it. I mean, this is there's a union find E thing here, right? Yeah, because then you could jump. Because you could jump to the right, you jump to the left, and you could go back to the right. So it's a free move. Maximum. Okay, so it's a union find. Well, yeah, but you can do it with union find, but you have to. Or it's the same idea with connected components, but I don't know if union find is the way to do it. Or being able to do it without being n square. I guess maybe that's fine actually. How would you even... Is it union find? Maybe that's not quite the right way to say it. Because for example, you have like 1, 5, or let's just say 4, 5, 2. Then 2 can go to both of these, right? But it's not a union find per se, because you can't go from 4 to 5. Okay, so what am I saying here? I mean, it is some sort of DP. I have to figure out what that means. Man, today is just a rough day. Like, I have no idea. And it's just about going to the max value. Can I go backwards? Right. And then just, if we go backwards, then we just calculate them all at the same time. Okay, that seems reasonable. Okay, so then what happens if you go backwards? That means that, okay, if we go backwards, then you can go backwards to the right if they are bigger. Is that right? They could come up to us if the number, so now it's smaller, right? Why is the symmetry the same? Kind of confused actually. It goes to the, so going from the, I guess we said, okay, no, I think the symmetry is right. It's just a little bit awkward, or in my mind it's a little bit weird. So then we start at, it's like a shortest path or longest, it's not shortest. Can you do it that way then? You start with the biggest number, then what does that mean? That means that everything to the right, which is smaller, we can reach, and that they can reach to us. Right? Yeah, and then we don't have to do anything more. And then that means that, well, if you're the biggest number, then everything to the right is already smaller. And then now we find the second biggest number, and then everything to the right of that. Okay. So then we just have to figure out, well, no, that's okay. I mean, that's true, but that's only one side, right? On the left side, everything bigger to the left, we also mark as, no, if they're bigger, then by definition, you haven't calculated them yet. So everything to the right, smaller, set. The set. Is that true? No, not, I mean, yes, but not exactly, because here you could go from 2 to 1 to 3. So not quite. We're here. Yeah, okay, so let's see. So let's start again. So biggest number, everything to the right, or to set to that number. And then now, starting from that number to the left, okay, what? He wants to be able to the right, maybe. Well, if it can't go any number to the right, like if it's the smallest number, then it's the biggest number to the left, right? Is that right? Biggest number to the left, and then keep going, and then just a for loop, maybe. Definitely feels awkward though. Huh. No, I mean yes, but this, if it goes to the second biggest number, that, because you can go, so the smallest number can go left to the bigger number, and then it goes right, and then it goes left. So what is general rule? Okay, so biggest number, and then just slowly go down. So sort by that and then process. Is that sufficient? I don't know. Let's give it a try. I don't know. Right? I don't know. Reps. No. Well, I mean, yes, but index first, right? So right? No, we want max first. So yeah, and I think tiebreakers don't matter anyway, so I think that's fine. Okay, so then now, what do we say? We'll say every number to the right of it will get set to that number. Then the next biggest number, I mean, that's fine. Maybe. Yeah, because every number. Okay, I think it's fine. It's just it feels awkward, but I think the amortization is fine. Okay, what am I doing? Okay, I think the amortization is very awkward actually, but it should be fine. Okay, so X is the biggest number we've seen so far, and then now we go everything to. As long as you make sure. That's awkward. We have to. It doesn't. Okay, so we set something to done, but yeah, okay. So answers of x or index is equal to x, just because right now it's the biggest number, but then now. By definition, all the numbers we've seen. Okay, so maybe. No, I mean you can. I mean you can, but not specifically like that. Right? How would I write it? I think the idea is right, but I don't. But maybe it's not quite precise enough. The queries. It's a monotonically increasing thing. Is oh no, I mean yes, but also no. I mean yes, but also there's the thing about going back. That's why. Okay, I mean I get it. I think maybe I don't do this quite like this yet. Maybe we do a sweep. So it's a prefix max almost. Okay, so then that gives me all the everything to the right thing. And then the question is then can you go to the right to go to the left? And that's a query we have to figure out how to enter smart most thing. How do we go through those? Binary search. Yeah, okay, this is like an LIS actually, right? Then now, yeah, let's say if x is not equal to mx, then that means that it went to the, it is an answer from the left. Then we want to, if x is not equal to mx, then we want to keep the smallest, right? So something like that. I guess this is fine too, really, right? Is it key? Lambda. Blanking out today. Oh no. Okay. So then let's put it out real quick. I think this gives me the answer I kind of want. So 2, the smallest is going to be 1, 3. So then now this is going to be what does this mean? I mean, we need to do a prefix backwards, right? Because it means that if you're 2, then you could go to a 1 later, right? So we have to do a prefix backwards, right? So maybe for key value in f.items, we want to sort by the key. Right. Oops, the other way around. And then I want to write this, but I think that actually oh, I mean, I think it does, but I think I just have to convert it to a list. Let's go to value. I think that's fine. Let's run it. Okay, don't give me a concurrency thing. Did I mess up F? Oh no, I got smallest. Why did I? I think F is the frequency. We're lazy. Oh, whoops. Okay, and this is Did I not do this right? Oh, Dumbo. Okay, so then now we go over it again, right? Now, does this help? Well, okay, now we have this, and we want to be able to binary search on the keys, right? Guess that's the thing. Because then for each number, we want a reverse thing. Any number. Because then now every number with a 1 gives you a 3. In this case, it's every number. Does that look like for here? So then now 1 gives you a 2, and then 3 gives you a 3. So then you binary search on the thing, and that should be fine. Okay. So then now we have we want to say let's do this again. Just throw it out. Because technically you don't do it in reverse anymore. And now we just have a binary search of yeah. I need to be a little bit cleaner on the 1, 2, 1, 3. I mean, maybe I don't write it this way. Maybe I write it in the based on the value. right? Maybe I have some, I don't know, just call it F now for now, whatever. Right. And then now this means that f of n is equal to basically max of f of mn, or the key, yeah, okay. And now we have that. It's a tricky one. I'm going very slowly, but I don't even know Q2. Oh, it's kind of bad. Okay, so yeah, this is what we want. And then now we can just go by, yeah, okay. So then now for KV and after items, we just put it in a sorted list. I mean, I don't actually even have to put in a sorted list because we can just sort it once in a binary search. I'm still going to call it sorted list. We want to put it in a key value. I think that's fine, maybe. I think that should be fine. And now for I range of n, yeah. Okay, then now we binary search SL on this being the key value, and then they should always give something. So then now SL of index of element 1 is the answer, right? Something like that. Yeah, this is a very hard problem, or just annoying for me. Okay, maybe I was wrong. Did I get this one wrong? Why? Oh, I forgot to sort it again. I mean, I think this is reversed, but either way, I think this is fine. Still wrong though, huh? I did know, I did try to remember to sort it, but I just forgot. 1, 3, so that's wrong. Huh? I did have like different things. Am I looking at the wrong one? Oh, I guess this is, it's only one for, I don't like that they jump around the problems, or the test cases. Okay, so this is right, but it is binary searching for, oh, huh, I did it, I mean, this is kind of right, but I think I did it in the wrong way. So actually we want this, and then index -1, I suppose. This stuff like this always makes it's a little bit awkward. Yeah. This is wrong though. The 2. Search to 2. Why do you find? How do you even get to 2? Like how? Oh, I will index instead of I. Alright, that is just pretty bad. But I mean, yeah. YOLO submit. Hopefully, nothing too silly. Is it a misunderstanding or a thing? Expected is 11. Oh, it has to be strictly smaller. Okay, I mean that's a easy fix if I could figure it out. That's actually that changes it a little bit. I have to think about it. That is actually a little bit messy, because then now I can just say every 11 or higher goes to 18, because in this case that's not true, right? Okay. I might have to. This is. I'm very annoyed because that's actually not a small change. Maybe I'm wrong. I made some assumption there. I mean, I think this part is still right, or this part anyway. 11 has to find a number smaller, but I try to simplify it a little bit too much, I suppose. Okay, definitely not. It is just so then. Yeah, I mean, I think this is fine, honestly. We just have to go backwards. And then binary search again, but it's a little bit weird, right? I mean, it's not even gonna have time for Q4. This is a disaster. What is F at this point again? I forget. F at this point is 11 saying 18. Okay, so that's. Oh, this is the going backwards part. And 18's min is 11. I get a water. I guess maybe I could have done it with segment tree, honestly. Maybe that is the way to do it. Because it's just updates and mins and stuff like that, but that's really like, okay, I don't have time, so let me look at my segment tree stuff. What do I want? I want range update and also range min. Alright, I don't know where I got this from, so maybe it doesn't work, that'll be funny. Okay. Which version is this? Oh, this is the iterative version actually, so that's kind of cool. Alright, no it's not. But, alright. No, do you want the min? No, you don't want the min. I mean, you want the min. It would be nice to have the min, but what you actually want is some sort of mono stack, right? Because you want. No, you want the min. No, do you want the min? No. Do you want the min? Maybe it's not segment tree. Today is just a struggle. We're so close. Okay, go backwards. What are we doing? All the numbers were upgraded. Okay, we're fine. And then now, question is, for every number inside those chunks, can you upgrade? I think what I was doing is so almost right that is frustrating actually. That's why I'm like trying to, maybe I'm just stuck a little bit in my head as a result. This is a little bit off as a result. I could just subtract everything but what I want. That would be funky. Jeez, I'm 45 minutes in and I got one problem. This is maybe one of my worst contests ever, but okay. Okay, so for every number inside those intervals, we want to know no, I mean, I think this is fine. We just have to know. So for a number outside of it, we just need to do a +1 maybe? I have to just incorporate these two together, I think. In a way. Maybe I just need to do a +1 somewhere. And this maybe has done backwards. This, I mean, this probably works, but I have to do it in another way. The smallest array is wrong. It's the smallest of max, right? But if you're jumping into it, and also you can do multiple jumps, Larry. So it's not even quite true that you can just do a +1. Oh. Huh, I am dumb. You can jump to. So actually, no, I got this all wrong. In this case, you can't though, but and it's wrong for a different reason, but I'm wrong for another reason. Because then, no, I think I collapsed this, right? Because that's what the collapsing does. Maybe I'm just confusing myself now. So basically, given this number, we look at the max. Okay, so every number, let's step back. So every number we want to make it go to the max on the left side. Okay. And then we just collapse adjacent numbers. Because in this case, 11 is the max, that's why. It's not that I did the even thing. I mean, that's a little bit off, but 11 is the max. So then we want, so we have to go back to here, right? Yeah, I mean, I always submitted, I can get it back. But, okay, so we have this, and then now, that means that okay, I think I get it now, maybe. I mean, I think I just need to also not do it this way. which is if x is greater than mx, then mx is equal to x. But we'll also maybe start a new region, right? Maybe off region and index, right? Right? Current is equal to index, maybe, and then r of current, and this is the min thing actually. So maybe this is, maybe I'm doing the same thing in this in a different way. Okay, okay. So you have region. Okay, but now we're doing it by index, right? Yeah. Okay, so then now we have the region min, and then now we go backwards maybe. I don't know if this makes sense. But yeah, and because then now we can go backwards. Maybe AR to be more precise. Because then AR of J is the thing, and then we want to see if it collapses into the previous one. Right? So that means that if the min element of this, okay, fine. The regions, so okay, let's just call it index is equal to this, and then all of the, this is the smallest number. So if this smallest number is smaller than the biggest number in the next region, so I have to do this backwards actually, but j minus 1, then if this is the case, then we just merge, right? Then that means that AR of we could just do we could dedupe later, but we could just set that as equal to index. If it's greater than that, then now I saw this in a weird way. It's not current anymore, so that should be just index. Yeah. Yeah, maybe I could win this better. But I think that's mostly how. And then if on a merge, my head is just not thinking today. On a merge, okay, so you merge and that's fine. And I mean, we could do a linear loop. I think it's fine. It amortizes from range from that index all the way to this index. Right. Equals something like this. Though this is wrong, but no, this is right. I wrote this in a really weird way, so I might just be messy. I don't even return an answer. And also this is answer. 2, 3, 3. I mean, this is wrong, so that's no good. But do we merge? Nope. What am I printing? So what are my maxes? Maxes on 0 and 1, that's right. So what is AR? AR is the index, so that doesn't even make sense. We need the all of this. Merge, okay, so merge is okay, but it is not actually merging, which is not as okay. It's because we update this before we update the merge, so we need the old index. Okay, okay, okay. Is it good? I don't know. I might get like 5 wrong answers, but we have 36 minutes left, so I'm not even close to being done. And we are clearly not done. I mean, my idea is still like it should be able to handle this, but it doesn't clearly. So, I don't like the setup I have here, but it is what it is. Pre-index is good. I should have done this to begin with. No, this I need to. Okay, I mean we need to figure this out, but now we can maybe look at AR and maybe R, right? We stop at 0 and 3, so that's right. 0 min is 5, that's right. 3 min is 24. All right. So we look back. Oh, this isn't right. That doesn't make sense. It's nums. We want the biggest number, right? So then now it merges. Yep. Okay. I don't know why. I think I got confused when I was changing it because the other one was definitely wrong. Maybe what I changed it to is slightly more right, but this is still wrong. Oh, 9 goes to 6, but okay. I mean, that makes sense. I mean, I am not testing as much because I am so far behind. But I think I should be able to handle this case other than a silly mistake. So 0, 1, 4, that's right. 0 is 9, 1 is 6, that's right. 4 is 9, that's right. We should merge. So I don't know, something's not merging quite right. There is a merge. We go to this doesn't seem to. Well, I mean, I guess we have to also min the other number. Maybe that's why. Merge equals 4, 4 to 4. Oh, 4 goes to 9, and then update the previous index instead. Okay, so that's why. I mean, I think we probably should do this anyway, but we should also just update this. I think maybe that fixes it. That is a little bit wonky, but I don't know. At this point, I'll take wonky and correct for now. I should double check all the other things, but thanks for watching, everybody. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about each problem, this contest, everything in between. Stay good, stay healthy, take your mental health. I'll see y'all later and take care. Bye bye.